Okay, here we have notes for Algebra 8-3 on geometric sequences. So a geometric sequence, excuse me, no, that's not going to work. Okay, better. Okay, geometric sequence. It is a type of discrete exponential function. In the previous lesson, we looked at arithmetic sequences that were a type of discrete linear function. So these ones are just exponential. So remember the fact that it is a discrete function tells you that you are using integer values only, right? So whole numbers only, no decimals, no fractions. And that when you graph them, you don't connect those points. So two important things that basically what discrete means there. Okay, so since it is exponential and not linear, that means that it does not have a constant rate of change. It has an average rate of change. Meaning it's not the same, not constant. You're not adding or subtracting by the same. Right? Average rate of change refers to addition or subtraction. I don't want to write that down though, because I don't want you to confuse that. Not linear. And so what it means to be exponential, or what it means to be geometric, those two words are going to be interchangeable now. That means that there's a multiplying factor, right? You're multiplying by the same amount each time. Right, that's what it means to have a constant rate of change, to mean that you are adding or subtracting by the same amount each time. But when you're talking about exponential or geometric, you have that multiplying factor, where you're multiplying or dividing, right? It could be dividing. Just keeping in mind that every division can be written as multiplication of a fraction, right? So if I'm dividing by 2, that's the same thing as multiplying by 1/2. Oops. Okay. So multiplying by the same amount each time, that is what's now called a common ratio. Which makes sense because if you think about a ratio, the most common way to write a ratio is as a fraction, so we could have multiplication by that fraction. And different name, other name, aka for your common ratio, as we talked about, is that multiplying factor. Okay. So exponential, the first thing or the equation that should be coming to your mind when you think about exponential is that y equals a times b raised to the x power. So this time, instead of using, x and y, we're using a of n, for function notation. That a piece represented my y-intercept. Our y-intercept, remember, we're going to write this at the top for a bajillionth time. A sub 0 is my y-intercept. So instead of just putting a, we're going to put a sub 0, parentheses. Our multiplying factor, which was formerly known as b, is now our common ratio, which we are going to be using the variable r to represent. And then instead of x, we are using n. So same kind of formula, just different pieces. One's written as a regular equation and the other one is written in function notation. We could do that one more time, turning it into sequence notation with the a subs, which would look exactly the same as the one above, except instead of parentheses for of n, it's sub n, a subscript. And just labeling that this is our function notation and this is sequence notation. all three of these equations are the same thing. All right, examples.